Hello everyone. In last video, we saw a brute force all pair sum approach with time complexity O of n squared to solve TwoSum problem. In this video, we will look at suboptimal approach sorting with binary search. This is better than brute force approach in terms of time complexity. In future video, we will look at the optimal approach. Let's talk about on how to approach to the solution of the problem. In brute force, we checked sum of each possible pair in nums to see if it's equal to the target. We did it by adding nums of I plus nums of j and checking if it's equal to the target. From the brute force approach, we can infer the idea that for current element I, we are trying to find its complement pair jth element in nums array, where complement pair is equal to target minus current element. That is nums of j equal to target minus nums of I. So if we are at 7, then we want to find its complement pair, which would be 26 minus 7, 19 in rest of the nums array. From this we can say that TwoSum problem involves search-based solution where we are trying to search complement pair of current element in rest of the nums array. Whenever a problem is based on search-based solution, I always ask myself a question. Can I apply sorting and leverage binary search to simplify the problem and do a faster search? This is because binary search operation is O of log n time, which is faster than linear search, which is O of n time. For folks who are beginners, this may not come intuitively, so tip for you guys would be whenever you identify a problem which involves search-based operation, always try to see if you can use sorting and apply binary search on top of it. This is to simplify the problem and improve the time complexity. Let's see how to apply sorting and binary search in solving TwoSum problem. Let's apply the solution we talked on this test case, where nums is 7, 11, 2, 15 and target is 26. The expected output is 1, 3 because 11 plus 15 is equal to 26. For each input array nums, we will convert it to nums with indices array, which will be sorted. This will keep track of number value in nums and its index. We keep track of index in nums with indices because in our output we return indices of pair of elements. After generating nums with indices, next we will traverse the nums with indices array. So we'll start our traversal at 0th index where I would be pointing to 2, 2. We'll try to find the complement pair of 2, which would be 26 minus 2, 24 in rest of the nums array using binary search. Since 24 is not present, binary search will return minus 1. We'll increment the ith pointer. I would be pointing to 7, 0. Now we'll try to find complement pair of 7, which is 26 minus 7, 19 in rest of the nums array. Since 19 is not present, binary search will return minus 1. We will increment the ith pointer. I will point at 11, 1. We'll try to find complement pair of 11, which is 26 minus 11, 15 in rest of the nums array. This time binary search will return 3 since we have found our complement pair of 11. So we will return the indices of 11 and 15, which is 1, 3. Now let's code the solution up. We will generate nums with indices array. We will do this by traversing through each and every element of nums and we will capture its number value and index. We will sort the nums with indices array. We will traverse through each and every element of nums with indices. We will extract the number value and its index. We will calculate the complement pair, which would be target minus num. Next would be to see if this complement pair is present in rest of nums with indices array. We'll do this by calling binary search function and passing complement pair as the target. Let's code the binary search function. We'll initialize left and right. We'll start our binary search operation with while loop. The condition would be left less than equal to right. We'll calculate the mid index. We'll extract the mid number and its index from nums of mid. Now we will check if mid number is equal to the target. If yes, then we have found our complement pair and will return its index, which is mid num index. If target is less than mid number, then our complement pair is in left subarray. So we'll do right equal to mid minus 1. Else the complement pair is in right subarray. So left equal to mid plus 1. If complement pair not found, return minus 1. Now we'll check if complement index is not equal to minus 1 and complement index is not equal to original index because we don't want to reuse the same element twice. We'll simply return original index and complement index. Let's submit the solution. It got accepted. Let's do a time complexity, space complexity analysis of our code. In line 16, we traverse through each and every element of nums. So the time complexity would be O of n. Nums with indices takes O of n space to store num values and its index. Line 17, we do sorting. So the time complexity would be n log n and space would be O of n. For line 18 to line 23, the time complexity would be n log n. This is because for each element we are doing binary search to find its complement. So to traverse through each element in nums array would be O of n, and doing a search operation to find its complement pair would be O of log n. So the total time complexity would be O of n plus O of n log n, and the total space complexity would be O of n. In next video, we will explore one more popular search technique based on sorting solution to solve TwoSum problem. This would be a suboptimal approach. And in future video, we will look at the optimal approach. So thank you for watching this video and stay tuned.